Now, as you probably guessed, the last lecture, the demand curve in the last lecture in the graph was highly orchestrated. I essentially knew beforehand the outcomes, etc. Because I had set up the graph like that. But let's take some more sort of arbitrary demand curves and use some more application to or for the midpoint formula. Let's apply that formula a few more times with just some extra examples. So assume I have a demand curve, and all I have on this curve are two corresponding prices and quantity demanded. Okay, so let's say I have a price of 4 and a price of 2. Corresponding quantity, say, is 15, and corresponding quantity is, say, 20. Let's make it odd. Let's make it hard. Say 23. Okay. So at a price of $2, 23 units are demanded. At a price of $4, 15 units are demanded. So let's employ the midpoint formula. So what we have is changing Q is 23 minus 15. Now I'm going to keep the absolute values out of here because, again, I don't need them. Okay. 23 minus 15 divided by 23 plus 15 divided by 2, and that would be over the change in price, which is 4 minus 2 divided by 4 plus 2 divided by 2. Okay, and this equals 8. 23 minus 15 is 8. Divided by 23 plus 15, which is 38, divided by 2, that would be 19. Divide that by 2. 4 minus 2 is 2, divided by 4 plus 2, which is 6, divided by 2, which is 3. Okay, now, doing something like this, we need to break out the trusty TI-85 calculator. Now, I'm not pushing Texas Instruments. This is just a YouTube video. I'm using a TI-85 calculator. You can use any calculator you want, doesn't matter. 8 divided by 19. So I'm going to put a little approximation symbol on here. So 8 divided by 19 is approximately 0.42. That, of course, is 2 divided by 3, which equals 0.67 approximately, and we get 0.42 divided by 0.67 equals approximately 0.63. Now, as we can see, this is less than 1. Okay, so demand is elastic. Demand is inelastic. That's less than 1. Demand is inelastic at this midpoint here. So that E sub x equals 0.63, which is less than 1. Okay, so demand is inelastic at that point. Now, using the total revenue analysis we had earlier, at this midpoint, okay, which corresponds to a price level of 3, okay, and a quantity level, which is, of course, 19. At that price of 3 and a quantity sold of 19, if I wanted to maximize my revenue, what would I do with the price? Well, the elasticity value is less than 1. We know at unit elastic price levels, revenue is maximized. Therefore, I'm not maximizing my revenue. And because the inelastic portion of a demand curve is below the unit elastic price level, remember this. So if I've got a demand curve the midpoint of that entire curve is unit elastic. Above that point is elastic. And below that point is inelastic. Okay? Currently, the price of my product, okay? Currently, the price of my product is below that point because I'm in the inelastic portion of my demand curve. So if I want to increase my revenue, I would want to raise the price of my product. Will I lose sales? Yes, due to the law of demand, but I'm going to cram more cash into the cash register. Okay, let's go over another example. So we've got a demand curve, and let's say I've got a price of, I don't know, $15. And at $15 a unit, I'm selling 1,150 units at a price of, say, $6 per unit. I would sell approximately, I don't know, say 1,800 units at $6 per unit. Let's calculate the price elasticity of demand between these 2 points. In other words, a price elasticity of demand at that point, right there, between the 2 price levels. Okay, using the midpoint formula, we've got 1,800 minus 1,150 divided by 1,800 plus 1,150 divided by 2, and all that would be over the change in price, which would be 15 minus 6 divided by 15 plus 6 divided by 2. Okay, and so what do I have here? Well, breaking out my trusty TI-85 again, I got 1,800 minus 1,150, which equals 650 divided by 1,800 plus 1,150, which equals 2,950 divided by 2, which is 1,475. And I divide that by, I can do this in my head, 15 minus 6 is 9. Okay, divided by 21 divided by 2, which is 10.5. Okay, so what is this overall? Again, I'm going to use an approximate sign. 650 divided by 1475 equals approximately 0.44. Divide that by 9 divided by 10.5 is approximately 0.86. Okay, so the elasticity value here then is 0.44 divided by 0.86 equals 0.51 approximately. Okay, so once again, at this midpoint, we get an elasticity value that indicates demand is inelastic at that point. So again, what would I want to do with the price level if I wanted to increase my total revenue? If I wanted to cram more cash into my cash register, I would want to raise the price level of the product. Now, let me throw you a little trick. Assume that this is my demand curve, and assume at the horizontal intercept is say 100,750 units, and assume at the vertical intercept that's at a price of $112. Calculate the price elasticity of demand. Well, you're probably going to say, well, I only have the 2 points. I don't have 2 prices and 2 quantities. But you actually do. Okay, you've got the origins. Now you go ahead and crank this out in the formula, okay? But what you're going to get is essentially this: 100,750 divided by 1/2 of that, okay? Which is 100,750 divided by 2, which is 50,375. And then the price is going to be essentially the same thing. You're going to have 112 divided by 1/2 of that, which is 56. In other words, you're going to get 1/2 divided by 1/2, which equals 1. Again, what was the point of that experiment? Just to prove to you, it doesn't matter what the intercepts are. The midpoint of a demand curve, in other words, in this case at a price of 56 and a quantity demanded of 50,375, at that point demand is going to be unit elastic, and it's at that point that total revenues will be maximized.